Welcome to 3 Dimensions. In this lecture series today, we'll solve examples 2.8, 2.9, 2.10. Let's solve example 2.8 now. So the question here is to calculate the temperature difference. So what are the given values here? T1 equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius. T2 equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. The question is, calculate the temperature difference and the error there. Now let us note down the given values. T2 equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Now, question is temperature difference and the error. So we've got individual values here, right? For T1 we've got a value. For T2 we've got the value. So we've got individual errors in both the cases. Now the question is, if we calculate the temperature difference, what is the error there? So if there was no error, okay, if it's a question that is just T1 is equal to 20 degrees Celsius and T2 equal to 50 degrees Celsius, then what is the temperature difference? Right, it is 50 minus 20 degrees. So then you get 30 degrees Celsius. But the question here is calculate the error. Now what do you do in the case of error? How do you calculate the error? In the case of temperature difference, how do you calculate the error? So even if it is subtraction or if it is addition, so if it was T1 plus T2, it is the same thing, okay? So for error, what do you do is we sum the errors. Even if it's addition or subtraction, it is summed. So the error will be delta T equal to the error, total error, right? The total error, okay, the subtracted temperature difference error, right? That will be equal to the sum of the individual errors. What is the individual error of T1? That is 0.5 degrees Celsius. What is the individual error of delta T2? What is the error of T2 value? 0.5 degrees Celsius. Now, to find the total temperature difference error, to sum it. So what do you get? 1 degree Celsius. Now, just like we've written T1 equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius, you have to write the final values. So we know from the above calculated that the temperature difference is 30 degrees Celsius. So it will be, the final answer will be 30 degrees Celsius plus or minus 1 degree Celsius. That is your final value. Let's solve example 2.9. Here the question is, the resistance R equal to V by I, where the values of V and I are given with their errors. The question is, find the percentage error in R, right? So they're asking for delta R by R into 100 when it comes to percentage error. So we write down what do we need to find out. Now, how do you calculate the error if it is division? We saw in the previous example, if it is addition or subtraction, you have to add the errors. But what if it is division or multiplication? Here, delta R, the error R divided by the original value will be equal to the error of V divided by actual value of V plus the error of I divided by the actual value of I. So this is in the case of division, right? For both division and multiplication. So R equal to V by I, this is how we solve it. Now if the question was V equal to IR, find the error of V, then how do you do it? Same thing. Error of V divided by the original value equal to error of I divided by the original value plus error of R divided by the original value of R. So division and multiplication, this is how you find out the error. Now let's go to the question. So this is the formula. The division or multiplication, this is the formula. Now let's go to the question. So the question here is, resistance is given, value of V and I is given, find the percentage error in R. Let's note down the values. So delta R, we're finding the error here, right? So R is equal to V by I. So how do you write the error? Change in R, error of R by R, error of V by V plus error of I by I. So what is the error of V here that is given to us? 100 plus or minus 5 volts, right? So 100 is actual value, 5 is the error. So here the value will be 5. The error of I is 0.2, value of V is 100, value of I is 10. Now let's write down the values. The error of V is 5. Actual value of V is 100 plus error of I is 0.2. Actual value of I is 10. So we get the sum of this to be 7 by 100. Now what is the percentage value? Percentage error. In order to find out the percentage error, we have to multiply by 100. So we get the value, the percentage error to be 7%. So this is a final value. Let's solve example 10. So the question here is two resistors of resistance R1 equal to 100 plus or minus 3 ohm, R2 equal to 200 plus or minus 4 ohm. So these are the given values, right? The question is, they are connected in series and in parallel. The question is, find the equivalent resistance when it is connected in series and in parallel. So we've given the relations that have to be used. So in part A, when it's a series connection, part A, when it's a series connection, we do R equal to R dash, that is equivalent resistance, equal to R1 plus R2. So without the error values, how would you do it? We just add the values, right? So we get 100 plus 200. That will be a direct value. 100 plus 200, that is 300. So the equivalent resistance value is 300 ohms. But what about the error part? So the error is in the case of subtraction or addition. How do you find out? We have to add the errors. So the delta R dash, the equivalent resistance error here is delta R1 plus delta R2. Okay, that is the individual values. So the error of first resistance is 3 ohms. The error of second resistance is 4 ohms. Now you have to add them. Once you add them, you get 7 ohms. So then our final answer is the resistance value 300 plus or minus 7 ohms. That is our final answer in the case of series connection. Now let's solve part B. What if it is a parallel connection, right? So in this case also we have to find out the equivalent resistance and the error, right? So what is, in the case of error, what is the formula here? They've given the formula in case to calculate the equivalent resistance and also the error value. They've given both of them. Okay. So calculate the R dash. Write down the formula, the equivalent resistance formula. That is R equivalent value is 1 by R1 plus 1 by R2. Once we simplify this, we get R dash equal to R1 R2 divided by R1 plus R2. That will give you the equivalent formula. Now substituting the values. 100 into 200 divided by 100 plus 200. That these are the values of the resistance. So that will give you, so the value is 200 by 3. That will give you 66.7. Now in order to find out the error, right, they have given us the formula. We just have to write down the formula. The formula is there in the question to find out the error value. Now how to find out the, now you just use this method to find out the error. It's a direct, we just have to directly substitute the values and find the answer. So let's do error values. Write down the formula. Delta R dash by R dash square will give you delta R1 by R1 square plus delta R2 by R2 square. So substituting the values, 3 by 100 square plus 4 by 200 square. And we know the value of R dash square, right? We found out R dash value, we found out the current resistance. So that will be 66.7 square. So solving this equation, you get the value to be, the final value, delta R dash, we find the value to be 1.8. That is your final value. That is your equivalent resistance value. Equivalent resistance error value. So in final, we can write the equivalent resistance as 66.7 plus or minus 1.8 ohms. That is your final value. We got the 66.7 value from there, the equivalent resistance formula, and the error from this equation, 1.8. Thank you for tuning in. Stay tuned for more videos on units and measurements. Thank you.